Hi everybody, today I'm going to take some time to go over the 2.1 through 2.5 review. I'm just going to do every problem as if I was doing it with you so that if you need some help, you can use this to clarify how to solve each one. This first problem says solve by factoring. So remember, your first job is to pull out a GCF, which we don't have, and then you're going to factor using the guess and check method. In this case, our first two terms have to multiply to get to 7x squared, so 7x and x. And then our second two terms need to multiply to get to 24. So we could do 12 and 2, 6 and 4, 8 and 3, or 24 and 1. 12 and 2 seems a little funny. Maybe let's try 6 and 4. Or no, 8 and 3. 8 and 3, let's try. Okay, in order for them to multiply to be negative, we have to have one positive and one negative. So let's say this is our negative, here's our positive. Then we check by multiplying outsides and insides. Outside we'll get negative 21x, inside positive 8x is negative 13x. That worked. Okay, now I could kind of anticipate that it was going to work, but if you can't, just plug in 12 and 2. That won't work. 6 and 4. That won't work, so then you'd get to 8 and 3. Now to solve, we set these equal to 0. 7x plus 8 equals 0. So if we subtract 8 and divide by 7, x is negative 8 over 7. And then x minus 3 equals 0. When we add the 3, x is positive 3. Okay, in this guy, hopefully right away we can see that there's a GCF that we can pull out. Divide all of those by 4, which will get x squared minus x minus 20 is 0. Okay, now we need to factor. We know we're going to have x times x to get x squared, but then to get negative 20, we could do 4 and 5, 10 and 2, or 20 and 1. So 4 and 5, let's say, we know one has to be positive, one has to be negative. Our outsides give us negative 5x. Our insides give us positive 4x, which is negative x, negative 1, which is what we wanted. Okay? Now we have x plus 4 is 0, x minus 5 is 0. So here we get negative 4 and positive 5. Okay, now if I say simplify, these are complex numbers. In this case, I'm subtracting my complex numbers, so I need to distribute that negative to get negative 1 plus I minus 8 minus 7I. Now I have negative 1 and negative 8 is negative 9. Positive 1 and negative 7 is negative 6I. Okay, in this case, we have no operation in the middle, so that means we're multiplying, which means we are going to FOIL. Okay, first times first is positive 40. Outside is negative 40I. Inside is negative 48I. And last would be positive 48I squared. Okay, so I keep my 40. Now I have negative 88I. And then 48 times I squared will be 48 times negative 1. So that'll be negative 48 plus the 40 will give us negative 8 minus 88I. Okay, when I graph, I plot a point. So in this case, I plot A, comma B, which would be negative 4, negative 1, which is down here. Okay, over here, A, comma B, I have no A value, so 0, negative 2. Okay. Here it says solve by taking the square root. So if I'm going to solve by square rooting, here I've solved for everything, or I only have my term being squared, so I square root both sides. I get plus or minus, and I pull out an I to make that positive. Then in 12, I can say radical 4, radical 3. 4 is my perfect square. So I'll have x equals plus or minus, the square root of 4 is 2i radical 3. So x is positive 2i radical 3, and x is negative 2i radical 3. Over here, I need to deal with this 4, and I would not ever distribute it. That makes my life harder. I want to make my life easier by moving it over to the other side, so I divide both sides by 4. Now when I take the square root of both sides, I get x plus 1 equals plus or minus I, to make it positive, radical 2. Okay? So then I'm going to set up two equations. X plus 1 equals positive I radical 2. X plus 1 equals negative I radical 2. Then when I subtract the 1, here I'll say x is negative 1 plus I radical 2. And x is negative 1 minus I radical 2. Okay, that is solving by taking the square root. Next, I'm going to solve by completing the square. And remember, your first step is to add that current c, or subtract it, to make space for a new c value. Okay, to find that new c, we're going to do b, so 8 over 2 squared, which will be 4 squared, or 16. Okay, then we can factor this left-hand side to be x plus 4 squared equals 49. That 4 comes from up here where I squared 4 to get 16. Now I solve by square root method. X plus 4 is plus or minus, the square root of 49 is 7. So now I set up my two equations. X plus 4 is positive 7. X plus 4 is negative 7. When I subtract the 4 here, I get 3. Here I get negative 11. Okay, over here, 2x squared minus 12x plus 8, I can divide everything by 2, which will give me x squared minus 6x plus 4 is 0. So then I move that c value over. And solve for a new one. Negative 6 over 2 squared is negative 3 squared, which is 9. So now I can plug a 9 into both of those. And then rewrite this left-hand side as, oops, I'm sorry guys, x minus 3 squared equals 5. Now when I square root, I get x minus 3 is plus or minus the square root of 5. So I say x minus 3 is positive radical 5. And when we add 3 over, we get x is 3 plus radical 5. Then I could say x minus 3 is negative radical 5. So when we add 3 over, we get x equals 3 minus radical 5. Okay, that's completing the square. Here it says, find the discriminant of each quadratic equation, then state the number and type of solutions. Remember, the equation for the discriminant is b squared minus 4ac. So in this case, a is 9, b is 7, c is negative 2. So I'll say 7 squared minus 4 times 9 times negative 2. Now I'm going to pull up Desmos and do 7 squared minus 4 times 9 times negative 2 is 121, positive 121. Because it's positive, That tells me I will have 2 real solutions. Okay, over here, A is 2, B will be -1, C is 7. So if I do B squared, I'll say -1 squared minus 4 times 2 times 7. So -1 squared minus 4 times 2 times 7. Oh gosh. Is -55. Because it's negative, that tells me if I did quadratic formula, I would be taking the square root of a negative. So this gives me 2 imaginary solutions. Great. Actually, I might leave that there because next I'm going to use quadratic formula. Let's just review. Quadratic formula says x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So here, a is 1, b is -4, c is -6. So if I plug this in, x equals -4 plus or minus the square root -4 squared minus 4 times 1 times -6. All over top of 2 times 1, 2a. So -4 will be +4 plus or minus the square root of -4 squared minus 4 times 1 times 6 is -8 all over 2. Okay? Well, the minute we see that under the radical we have a negative, we should hopefully remember to pull out an I. So this gives us 4 plus or minus I, then radical 4 radical 2 is how we would simplify. Well, if I simplify that one more step, the square root of 4 is 2. Okay? Now, on your test, I would accept that answer, but the more correct answer is actually simplified. All of those, the 4, the 2, and the 2, can be simplified by 2. 4 simplified by 2, or 4 divided by 2 is 2. This 2i radical 2 will just turn into I radical 2. And if I divide that denominator by a 2, it just becomes 1. It cancels. So your 2 solutions here would be 2 plus I radical 2 and 2 minus I radical 2. Now you might say, why can't I simplify this 2? Okay, that guy is under the radical, so it is not a like term. It doesn't get simplified. Only numbers outside of the radical get simplified. All right, now over here, A is 2, B is -1, C is 11. So we'll say x equals -1 plus or minus the square root of -1 squared minus 4 times 2 times 11 all over 2 times a, which is 2. So again, -1 becomes positive. Now here we have -1 squared minus 4 times 2 times 11 is -87. Okay, that does not simplify, except we pull out our I. So our 2 answers here would be 1 plus I radical 87 over 4 and 1 minus I radical 87 over 4. Okay? There's your quadratic formula. So now we have a few questions where I say solve using any method. And any method means either factoring, and there's the steps for factoring, square root method. Now both of those only work some of the time. So if you want to pick a method that is always going to work, you either use completing the square or quadratic formula. Okay? Those are always going to work. That being said, factoring and square root methods sometimes can be easier or more quick. Like this first one, for example. That one is probably pretty easy to factor. In fact, here, if we try, we would get k times k to get k squared. And then in order to multiply to 42, we could do 6 and 7, 3 and 14, 42 and 1, 21 and 2. Let's try our first one, 6 and 7. For them to multiply to be positive or add to be negative, they both are going to be negative. So then when we check our outsides, we get negative 7k. Inside we get negative 6k. That's negative 13k. It works. So now I set my factors equal to 0. K is 6. K is 7. Okay, now let's say factoring is not your thing. You don't like to factor or you struggle to find the numbers, then just use quadratic formula. Okay, as long as you trust yourself to use it right, you should still get 6 and 7. Same with completing the square. If you'd rather do that, this one will get tricky because 13 doesn't divide by 2 evenly, so you'll get some decimals. But in the end, you should still get 6 and 7. Okay, here we're not set equal to 0, so let's subtract a 3. Okay, and as I'm looking, this one might be a good one for completing the square. Let's add that 51 over. So I solve for that c value. 5 squared will be 25. So here I'll get x plus 5 squared equals 76. And when I square root both sides, x plus 5 equals plus or minus square root of 76. Now if I start trying to see if this has a perfect square, let's see, 76 divided by 4 is 19, so 4 goes. So we would say x plus 5 equals plus or minus radical 4, radical 19. Okay. This turns into 2 radical 19. So then x plus 5 equals positive 2 radical 19. X plus 5 is negative 2 radical 19. When I subtract the 5, I get negative 5 plus 2 radical 19 and negative 5 minus 2 radical 19. Okay, do quadratic formula. You should get the exact same answers. Okay, if you feel more comfortable doing that method, do that method. Now this one, to me, yells out square root method, right? If we see that x minus 3 is being squared, we can just square root both sides. X minus 3 then is plus or minus 4. So positive 4 and negative 4. Oops, x minus 3. So when we add 3 to both sides, we get 7 and negative 1. Okay. Here, I would say GCF doesn't work because of the 3. I'm not really thinking I'll try and factor, so let's just use quadratic formula. A is 2, B is 3, C is negative 20. You might be able to factor, so if you'd like to factor, try that. Okay, x equals negative b plus or minus the square root b squared minus 4ac all over 2a. So negative 3 plus or minus the square root of 3 squared minus 4 times 2 times negative 20 is positive 169 over 4. Well, square root of 169 is 13, I believe. Let's just check. Yep. So negative 3 plus or minus 13 over 4. So now, when I set up my two equations, I'll say x equals negative 3 plus 13 over 4 would be 10 over 4, or 5 halves. And then when I do negative 3 minus 13 over 4, I get negative 16 over 4, which is negative 4. Okay, you totally could have factored now that I see those answers. So if you did, awesome. Multiply to 2v squared, add to negative 20. All right. This one looks like a square root method one to me as well. We could subtract the 20 over and then try and factor it as a difference of squares, but instead let's just use square roots. 9x squared will be 36. Then remember, we want to get x squared or whatever's being squared by itself, so x squared will be 4. Oh yeah, easy. X is plus or minus 2. So we could say our two solutions are 2 and negative 2. Again, you could have subtracted the 20 over and factored 3x plus 6, 3x minus 6, and solved. Okay, that would have worked just fine. Then over here, let's complete the square. Okay, we're going to add our 10. So we get m squared minus 18m equals 4. C will be negative 18 over 2 squared. So negative 9 squared, which will be 81. Okay, this turns into m minus 9 squared equals 85. Then when we square root both sides, we get m minus 9 is plus or minus the square root of 85. So let's see here. I don't think 85 can be simplified at all. So now I'm going to write my two equations. M minus 9 is positive radical 85. So when I add the 9, I find out that m equals 9 plus radical 85. And m minus 9 is negative radical 85. So m is 9 minus radical 85. Okay, now just to emphasize, for all of these problems, all 6 of them, we could have done quadratic formula. And if you feel comfortable doing that, that's great. But sometimes it's easier to use a different method. For example, 3 and 5, square root method was 10 times easier than going through the whole steps or all the steps of quadratic formula. 1, factoring was fairly simple, so we used that one. Okay, we used completing the square for 2 and 6, and then we did use quadratic formula for 4. Okay, you use what you're most comfortable with, and if that's quadratic formula, do it every time. As long as I'm not telling you which method to use, you get to pick. Okay, let me know if you have any questions, and I'll see you on test day. Group A, your test is Wednesday. B, it is Thursday.